for everybody who's not here. Okay. All right. So when we talk about the end behavior of a graph, what we are looking for is what happens on the right and left of a graph. So, are you guys with me that the right of a graph is essentially x approaching positive infinity? And the left of the graph is x approaching negative infinity. Good? Okay. So, when we talk about horizontal asymptotes are a type of end behavior asymptotes. So if I want to show analytical evidence that horizontal asymptotes exist, I need to show that the limit exists as we approach infinity and negative infinity. Are we good? Okay, so if I give you the function 2x squared over x squared plus 4, first of all, do you guys know the limit as those go to infinity and negative infinity? It would be infinity over infinity, wouldn't it?
Is that 0 or is it infinity? Or 1?
Not in this one. So let's start thinking through what that would be. By saying, to say that x is approaching infinity, I decided to pick values of x that get exponentially bigger. And also relatively easy to plug in. You guys, what is 2 times 10 squared? 200. So if I plug 10 into this function, I have 200 over 10 squared plus 4 is 104. All right. What if I plug in 100? What's 100 squared? 10,000 times 2 is 20,000 on top. And on the bottom, 10,004. This is just filling in 100 for x. And if I do 1,000, I get 2 million on top. Over 1 million for. Now, without even talking about the value of these fractions, there are plenty of seats in the front if you want to be able to see better also, is a thought.
I can see it, just my eyes can't tell.
It's a lot of zeros to process.
Yeah.
It's a lot of zeros to process. But overall, what is the value of the function as x keeps getting bigger and bigger and bigger? Are you guys comfortable saying this limit equals 2? So essentially, it's going to boil down to those lead terms. Now, this is a numerical approach to calculating this limit. We're going to learn some analytic approaches to calculating these limits, okay? Now, you guys, will any of these responses change if x is negative? Why not?
Because it's always squared.
Everything's squared. So, all right. So if I were to look at the graph of this function, I would have a horizontal asymptote at y equals 2, because on both sides, the limit goes, on both sides as I go to infinity, I get a number, 2. So the graph will get closer and closer and closer to 2. Everybody good? Is it ever going to equal 2? No, that plus 4 on the bottom is going to make it ever so slightly different. But, yes?
Is this the thing where you use the constants of the highest coefficient?
Yeah, you would have done that in Mr. Richards' class. I'm going to show you a different approach now that you guys know calculus. Okay. So, let's look at these couple graphs here. You guys, Do you guys remember what the graph y equals 2 to the x looks like? Perfect. Okay. Here's what we're going to do. We're going to plug some numbers in for x, and to find these limits, the first one we're going to find is as x approaches negative infinity. So what kinds of numbers should I pick? Negatives, yes. -1, -2, -3, -4. You guys, what is 2 to the -1 power? 1/2. Great. What is 2 to the -2 power? To the -3? 1/16. I can keep going, yeah? So are you with me that as x is decreasing, going towards negative infinity, the value of the function is like one, the top number always seems to be 1, and what's happening to the bottom number?
It's larger.
And it's going towards, keeps getting larger and keeps getting larger and keeps getting larger, the bottom number is. So we're kind of in this like 1 over infinity place. Everybody good? So from here on out, you can say that the limit, and the overall value of these numbers is going to 0. Are we all comfortable with that? That 1 over infinity is like so 1 over 1,000, 1 over 1,000,000,000. It's getting a lot. It's just getting closer and closer to 0. Okay, from here on out, in the same way, if you have a constant over infinity for this reasoning, you are now allowed to call that 0. And that's pretty much a huge idea, okay? So as I think of this, as if I have x approaching negative infinity, the answer to this is 1 over 2 to some infinite power. Is everybody comfortable with that? And if that is the case, that's 1 over infinity, right? Because 2 to infinity is infinity. So I'm comfortable with you calling this 0. We okay? All right, now, what about the limit as x approaches infinity of 2 to the x? Well, that is pretty much just 2 to the positive infinity, yeah? So that equals infinity. How are we feeling? Knowing that, I can say I have a horizontal asymptote at y equals 0. But in this case, it is only when x approaches negative infinity. Yeah.
Why is it at y equals 0?
Because that's what the y coordinates are going towards. Like when the limit is equal to something, you're saying what are the values for y? Horizontal asymptotes are of the form y equals. So the vertical asymptotes were what made the bottom equal to 0. The horizontal asymptotes are going to be what we get for our limit as we approach for those things. And in this particular case, the limit only exists going one direction, that way. Hence, we're describing our asymptote with an extra where x is going. Okay? So, what I will need to see in order for you to say a horizontal asymptote exists is that you show me that by showing that the limit as x goes to infinity or to negative infinity exists. Yes?
Why was it negative infinity in that?
So these two combined are getting me to this answer.
You're saying both?
Yeah. So when you want to check for horizontal asymptote, you're going to do two things. You're going to take the limit as x goes to infinity. You're going to take the limit as x goes to negative infinity. Okay? And if one of them is a number, like the limit exists, then you have a horizontal asymptote. Sometimes they'll both be, like up here, we can say there's a horizontal asymptote at y equals 2 and leave it at that because both limits go to the same number. Whereas for this one, they don't both go to the same number. So only one of them, only one side of it is a horizontal asymptote. Great question. All right, you guys, how is this one different? Well, if I plug this in right now, I have 1/2 to the negative infinity. Yeah? If I flip that over, it becomes 2 to the infinity, to the positive infinity. And so what is this limit as x goes to infinity? Infinity. If I do that here, if I jump straight to plugging that in, I now have 1/2 to the infinity power, which technically I can't do, right? But this is just our thought process. Which, you guys, can I do 1 to the infinity power? What's the limit of 1 to a power as that power goes to infinity? 1. You with me? So this becomes 1 over 2 to the infinity power, so 1 over infinity. So for this one equals 0. So for this one, we have a horizontal asymptote at y equals 0, but this one only happens as x is approaching positive infinity. Is this kind of helping to see through what this looks like? And then everything else that we're going to do on the next page is mostly about analytical techniques to do this. Most of them will be easy. 1 or 2 of them are going to make you guys want to throw things at me. Please, if you throw something at me, make it either chocolate or soft. One of the two.
How did you turn 1 to the infinity into 1 over infinity?
This is 1 to the infinity over 2 to the infinity. Think of it that way. So 1 to a power is always 1. Unless that power, you shouldn't actually think that. There's some components of that. But 1 to x as x goes to infinity is 1. I'm comfortable with that.
1 to x. Okay.
There's another component that is hairy, but we're not there yet. For right now, you can think that. How we doing? Okay, limit as. So let's go ahead and do this. So the directions are, what are the horizontal asymptotes? Okay, if I want you to find the horizontal asymptotes, we're essentially saying what is the limit as x goes to infinity? And what is the limit as x goes to negative infinity? Now, you're not allowed to use L'Hopital. If you're not allowed to use L'Hopital, somehow we have to rewrite this algebraically so that this starts to make some sense. So here's what we are going to do. As long as I multiply the same thing to the top and the bottom, I can do whatever I want, yeah? So what you're going to do is multiply the top and the bottom by 1 over whatever the highest degree term between the two of them is. So in this case, the highest degree term is x squared. You guys, what is x times 1 over x squared? 1 over x plus 3 over x squared over 1 minus 4 over x minus 5 over x squared. I'm going to give you guys a second. It's a 5 over. Now, here's the reason we do that. What is the limit as x goes to infinity of 1 over x? 0. We just said that we are now allowed to assume the limit as x goes to infinity of a constant over x is 0 every time. Okay, so the answer to this becomes 0 plus 3 over x squared becomes 0. 1 stays 1. Minus 0. Minus 0. So what is that limit? 0. And everything about this will be the same as x approaches negative infinity. So this particular graph has a horizontal asymptote at y equals 0, because that's what the limits are equal to. Whoever has the hiccups is automatically failing this course. I'm just kidding, I'm trying to scare you. Because scaring people is supposed to make you not have the hiccups anymore.
If they're not going away. One time I had them like all day last.
Have you ever heard of square breathing?
No.
Okay, I'm pausing this. If we use the exact same reasoning, what should I multiply by through this time? 1 over x cubed, because that's my highest term. So now I can say that g of x is equal to 4 minus 4 over x plus 5 over x squared minus 2 over x cubed And why am I doing this? This limit becomes significantly easier if I do it that way. So what's the limit as x approaches infinity of g of x? Four minus 0 plus 0 minus 0 over 3 plus 0 is 4/3. I can't even describe why I wrote 43. I was distracted by the hiccups. And for the exact same reasoning, as I approach negative infinity, I've got 4/3. Yeah.
Why aren't we allowed to use it?
We're not supposed to know what we told you.
Yeah, essentially, specifically on like my assessment guide, it says I can't give you credit if you use L'Hopital for this section. So I'm showing you the technique you would use if you don't know L'Hopital yet. Like most of the, Nate, put your hand down for a second. Okay, most of the students who are in this course at Columbus State have not taken AP and don't know L'Hopital. So these are the analytic techniques you could use, you can use to take limits. That's what this is about. Nate, what was your question, Bob?
Last year, we would kind of just look at this and just know it's 4/3, just like based on which exponent's higher and stuff. Are we gonna get to a point with that, or do we have to look over?
After the Unit 1 test, so after Friday, next Friday, obviously, you'll be I'm not going to care that much about L'Hopital. Is that okay?
Yeah.
So in other words, Unit 2 is all about how to take derivatives. Okay? You can't use L'Hopital if you don't know how to take a derivative, which theoretically you guys don't know. Theoretically. Because you haven't taken that yet. I am totally with you that I wish you guys could just use L'Hopital, okay? It would make all of our lives significantly easier. However, I can't go against what they tell me I have to do because I don't want to put either the credit in jeopardy for you guys and or them letting me do this for future courses, for future years, letting me be the one that teaches it. Does that make sense? Okay, you guys, so what does that say about the horizontal asymptote for this function? It is the line y equals 4/3. Done. It is what those values equal. This one? I already have 5 over infinity, yeah? So what I would expect to see is these two things. And then that you have a horizontal asymptote. Those are the two supporting statements that say you have a horizontal asymptote at y equals 0. Curious, did you have jazz band right before this?
No, jazz band is second period.
Because I could see maybe after band that causing more hiccups. Yeah.
I had them in third period, which was right after jazz.
Maybe 8th period band will get rid of them for you.
Oh, please.
It would be lovely, wouldn't it?
Well, I actually don't know if I'm playing in band today. Because I had my braces readjusted 2 days ago and my teeth hurt like crap.
Well, I'm really sorry to hear that.
Thank you.
Hey, what's this one? You have a 50-50 shot. You guys, if I plug in some really extreme negative values, so let's say like -1,000,000, which is arguably extreme. I have now e to the negative -1,000,000, which is like e to the million. Yeah?
Infinity.
So this one is infinity. So if you look at that, the negative infinity and the negative t suggest both are negative. The exponent overall is positive. Cool? And likewise then, what's the limit as t approaches positive infinity of 15e to the negative t? 0. So in this case, you have a horizontal asymptote at v equals 0 when t approaches infinity. I'll let you guys look that over because that's kind of there's more detail to this one because, you know, there's more detail to this one.
How do you know, how do we know it's not V? That doesn't make any sense. Because V can equal infinity.
Yeah, the horizontal asymptote happens when you have a value. for the limit. The limit has to exist for you to have that value. Yeah. Say that. So why is the asymptote at v equals 0?
Why is the limit of to purchase housing fees, why is that squared?
Okay, so let's start thinking through if I plug in an extreme value, like 1 million. What this would become is 15 over e to the 1 millionth power. And I could keep getting more extreme. What's happening then is I'm saying 15 divided by some really, really obnoxiously huge number, which is going to be like 0.00000000.
That's okay.
Cool? All right. Perfect. Oh boy. I just need you guys all to just stand up and stretch before we do this one together, okay? I'm dead serious. You guys need to stretch. Get yourselves ready for this problem. Stretching your arms and legs might stretch your brain. I haven't been able to touch my toes since I was like 7. Runners are not typically flexible. They have to work at it. Okay. What makes this problem complicated? The square root. Okay. And does anybody have any ideas on how you would like to attack this square root?
Square everything.
You can't,
Why?
because that would change the value of it.
If you,
Like if I square 2, I get 4, which is a totally different value than 2.
like,
This is what you want to do. Unfortunately, if it were that simple, I wouldn't have made you stretch for it. Yeah? So, I need you guys to trust me on why I'm doing what I'm doing, okay? Do you guys trust me? Okay. The first thing I'm going to do is rewrite just the square root as the square root of 4x squared times 1 plus 7 over 4x squared. I don't need you to quite understand why yet. I do need you to believe me that that is an equivalent statement. That if I redistributed that 4x squared, I'd be back to where I started. So I'm not changing the value in any way. So far, we good? So this is me showing you a strategy on how to navigate these square roots. Cool? All right. Now, I am allowed to split this up into the square root of 4x squared and the square root of 1 plus 7 over 4x squared. Are you guys good with that? Okay. Is taking the limit as x goes to infinity of this square root easy now? Because this would become 1. This would become 0 because that x squared is in the bottom. This one's not so bad. So now all we have is that square root of 4x squared that we have to manage. Cool? Can I take the square root of 4x squared?
wouldn't it still be infinity? Oh,
2x. You're really, really close. It's not quite 2x. It is, in fact, you're on the right track, but no, it is the absolute value of 2x. Still good. Now we are in a position where we can multiply by 1 over x. All right. So now as I take this limit, as x approaches infinity, you guys, as x approaches infinity, what is the value of the absolute value of 2x over x? 2, yeah? Are we comfortable saying this is 2 as x goes to positive infinity? Okay. Times. What about that square root? What's the value of this as x goes to infinity?
0.
Well, the value of this fraction is 0. The value of the square root is 1 plus 0. Yeah? The square root of 1. And on the bottom we have 1 plus 0. You guys, as I work that out, that looks like 2 times 1 over 1. We cool with this? All right. What about as x approaches negative infinity? What's the value of this as x approaches negative infinity? Negative 2? Are we cool with that? So this limit is equal to negative 2. So as I look at these two things, this is what I know. I have two different horizontal asymptotes. One is at y equals 2 when x approaches infinity, and y equals negative 2 when x approaches negative infinity. All right, we got one more example and then I'll be done. I know it's a lot for a Friday. Will multiplying by 1 over x help me in this one? It'll put me right back where I started because I'd have sine x over 1 on the bottom, which is still just sine x over x.
Do you need to?
So what we need to do is take the limit as x approaches infinity of sine of x over x. Now, we already learned that the limit as x approaches 0 of sine x over x is 1. This is not approaching 0, so we can't just use that rule. We have to figure out another rule. But this one is going to be much, much easier to figure out, I promise. We are still going to use the squeeze theorem, okay? But it's a much, much easier squeeze theorem. You guys, what do I know about the sine of x?
It's the y coordinate.
It's the y-coordinate on the unit circle, okay? And is it bounded? Yeah, sine of x is always in between negative 1 and 1. And so then what I'm going to do is I'm going to take this entire thing, and as long as I do it to each side of the inequality sign, I'm fine. Let's multiply it by 1 over x. So I get negative 1 over x is less than or equal to sine x over x is less than or equal to 1 over x. And for all of these, let's take x approaches infinity. You guys, what's the limit as x approaches infinity of this one? 0. We don't know this one. What's the limit as x approaches infinity on this one? 0. So I don't know the limit as x approaches infinity of sine x over x, but I do know that it's got to be in between 0 and 0, which means it is 0. And would that matter at all if we were approaching negative infinity? No, it's still going to equal 0. So I have a horizontal asymptote at y equals 0. I don't need to specify this one with where x is going because it's the same all the way across. And you are now allowed to just know that sine x over x as you go to infinity is 0.